So my name's Paul, and this is the front page of the HLM website. And to be honest, well, look at that. One team, one mission, one ethos, one vision. The only thing missing is the Queen soundtrack. But for me, the big problem for me is my one and only responsibility in the whole of HLM, as we have 6 UK and 3 international offices and about 200 or so employees and approximately 160 technical staff, is that I have to make sure that any one of those people in any of those offices, anywhere in the UK or in the Middle East or South Africa, must be able to work on any project simultaneously in any one of those offices. Every time I look at this slide, I think if only those countries were that close together and the same proportions, make life much easier. This is a program that we used to use, a CAD program, the best 2D CAD program ever, in my view. It's called MicroGDS. It was made in Japan. Like many good things. We stopped using this up to 10 years ago, I think, something like that. And it was amazing. We used to work as a one-team environment, just in the UK then, but also, check out that animation. That's PowerPoint for you. Death by PowerPoint. We had an office in Johannesburg. We had a long relationship with a company in Johannesburg, and it eventually became an HLM office. And we used to exchange files just by sending them down the VPN link, I think, back then, between Sheffield and Johannesburg. And the rest of the offices were all connected, and we could work in a 2D environment using MicroGDS quite easily. Back in 2005, this would have been our very first virtual building project using MicroGDS, this time in 3D, on a project which was a high school project in the city of Sheffield, which is in England. Only the structural engineer would participate with us in a 3D environment. We exchanged 3D DWG, so this predated any use of IFC. I love this slide. I show it to everybody, even friends and family, because the next one just shows you the second issue that we had of the structural engineers model, where it gets fixed. Isn't that brilliant? That was the first slide. First time we received the model, second time we received the model. Amazing. But what kind of BIM is it? Is it BIM at all? Is it BIM level 0, level 1, level 2? What is it? It's certainly 3D virtual building. We had full 3D coordination, visualization, we had linked information, we shared an extranet. Isn't that kind of the principles of BIMs, level 1, level 2, if you understand the principles of the different levels of BIM? Employer information requirements. We didn't call it back then, but we used to get briefs, we used to get room data sheets and fill them in, populate them in bespoke programs. And then the project was finished in 2008. This is an image from MicroGDS rendered in Piranesi. And that would be the real view afterwards. Here's a rather kind of uninteresting photograph here. Back then I was getting quite excited about the possibilities here. I came up with this idea: what if I could take a device to site, and I could, with some kind of handheld device or maybe even goggles, I could assess, the state of construction on the site, and maybe overlay the 3D model on top of the view that was in front of me. This is a little piece of software that I just mocked up at the time about 10 years ago. I rang my friend who was an inventor as well. I said, I need to patent this. I've got to patent this idea. It's really brilliant, and I'm going to make millions. And I did a little bit of research, about 5 minutes of research on the internet, and I found that it was so commonplace it even had a name. And that was augmented reality. And I created this little program called Area, Augmented Reality in Architecture. And obviously you can take dimensions and see labels. And this kind of software does exist. And I'll show you a few examples just towards the end. MicroGDS, it wasn't fully parametric. And it wasn't IFC compatible, which was a bit of an issue because obviously Revit was becoming quite popular in the early 2000s. The only way you could exchange full model data, the model information, and the information contained within the models was through the IFC system, and MicroGDS just didn't do it, which meant we had some big decisions to make, really. Many products on the market, and we were not tied to using Autodesk products, although we do use still some Autodesk products, I should say. And it came down to between two major platforms, really. It came between Revit and Graphisoft ArchiCAD. Back then it was ArchiCAD 13 in 2009. The thing is, we were planning to expand our network even further. So we were planning to move into the Middle East. We need to work in, like I said earlier, a full real-time simultaneous environment on any project in any office. And for one of those platforms, the cost was quite extortionate, really. We would need servers installing in every single office at a cost of, well, the cost was probably the GDP of the UK and Poland added together. So in the end, there was only really one solution, and that became ArchiCAD on the original BIM server system. Still, this was before the Middle East offices opened, but still between the UK and Johannesburg, we still had to exchange files across the network rather than working in a live environment. But essentially in the UK, we recreated the live environment, so any user in the UK could work on any projects in any of the offices in the UK simultaneously using the ArchiCAD BIM server system. And this was our very first project. This was another one of the high schools in Sheffield, but in a later phase. This is Bradfield School, rendered using a product called Atlantis from ArchiCAD. And that is the school as it is completed. There's another image, and there's the real view. This school has been open for several years now. This project was worked on between the Sheffield and the Glasgow offices, if that's easy to see. I know there's an outline of the country there. Before we made the switch to ArchiCAD, we had outsourced a modeling exercise to another consultant, and they produced this model using 3D Studio Max. This is a fire station in Omagh in Northern Ireland. It looks like something from Thunderbirds, but I think that's quite appropriate to have a kind of a superhero building for superheroes. This is the model recreated in ArchiCAD, and then that's the finished building. The value is only in the region of about £4.5 million, which would be 18 million Polish. This is one of my favourite photographs. It's one of my favourite buildings, and this is one of my favourite photographs. I think it looks brilliant. And this project was worked on between the Belfast office in Northern Ireland and the Glasgow office in Scotland, where I actually live. And occasionally we had the input of South Africa over there. This is another early model from 2011. This is a college campus in Sheffield again, actually. That's the completed version. It's won actually multiple awards, this project, so we're quite proud of it. This is a project that was only worked on between the Sheffield office and the Johannesburg office. This is where we did attempt to work in a live, real-time situation, and it was quite troublesome, but we managed to get through it in the end. So around about 2011, this is where the Middle East offices in Abu Dhabi came online. We were still swapping files just across the network, across the regular network, so we weren't working live. And at the same time, we won a project which is now the largest single building project using ArchiCAD that we've ever undertaken. This is the Royal Hospital for Sick Children and the Department of Clinical Neurosciences. Translate that if you can. In Edinburgh, in an area called Little France in Edinburgh. Valued at about £150 million, so is that about 750 in Polish. Quite a job. It's been worked on, or currently being worked on, in Glasgow, Belfast and Sheffield, but it's had the involvement of the Cardiff office, the Plymouth office, which is way down here on the toe of the UK, and Johannesburg, so everybody's had a go at some time, basically. When you're working on a project so large in one building, it's quite important to try and work out how you're going to break the building into manageable chunks. And that's not just for the file size, because the size of the entire project is about 30 gigabytes. So it's not the file sizes that you're breaking the building up for, but it's for the actual needs of the users. So for example, the landscape architects don't need to see all of the furniture and equipment in the building. They will only need to see the external envelope of the building. But the architects will generally need to see the external envelope and the internal parts, but not necessarily the FF&E. So you have to be quite careful the way you break down the building. So this is the kind of high-tech sketch that we would put together to try and work out how we're going to do this job. This is the current state of the network. We have quite strong links within the UK at 100 megabits and even 50 megabits to Johannesburg. But because of the expense, really, the link between Dubai, Abu Dhabi and the rest of the UK is relatively much slower, but probably about the same kind of price. It's very expensive to connect. This is where we trialed, I think in 2013, the Graphisoft BIM cloud system, which essentially it's like working locally because you have separate, what they call proxy servers or Delta cache servers in each office, and they manage the transactions across the water to the other offices or wherever the main project resides. And most of our projects now are using this Graphisoft BIM cloud system in a real-time live environment, even from Johannesburg and from the Middle East. That was the HLM BIM story. I want to just move on to level 2 and beyond. Possibly might upset a couple of previous presenters by contradicting a couple of things that they may have said before. So I apologize in advance. We're all friends though, so I don't think it really matters too much. But in 2015, December 2015, HLM gained a BIM level 2 status with the Building Research Establishment, the BRE. And in 2005, HLM joined the Building Smart organisation, which is soon to be part of the UK BIM Alliance. And that's possibly the case with there was a speaker earlier speaking about the Polish version of Building Smart. I'm assuming that organisation will become part of a BIM Alliance. But back in London in 2008, so this predates any properly defined standards or government mandates, I was there at the RIBA watching Mark Bew, who's the co-author of this BIM maturity model, which everybody has seen. And this is the actual slide, apart from the text on the left-hand side. And at the top it says, "Where are we?" And that red line there is where we were in 2008. It had absolutely nothing to do with any government mandate for April 2016. Not then, it didn't. It was where are we? And he said we were there. BIM level 2. Now, the definition for BIM level 2 wasn't released until the PASS document in 2013. This is 5 years earlier. And here we are, Warsaw, 2017. And what has changed? 2008, 2017. Well, it's actually the same. The BIM maturity model is the same, except that it has now become underpinned with a whole host of British standards and PASS standards. You have the BS 1192, which was written in 2007. That essentially defines the concepts of BIM level 1. And then you have the PASS 1192 2013 part 2, which defines BIM level 2 as we know it now. There are also the BS 8541 documents, which write all about object symbology, levels of definition, all of that kind of thing. That's the 8541. It's a really riveting read. I suggest you read every single one of those documents. But essentially, nothing has really changed. There's a phrase in English which we use quite often, which is moving the goalposts. Moving the goalposts, there's probably a similar phrase in Polish. Essentially means you have a set of objectives, and then the rules change, and the goalposts move. They get smaller, they move along, and it becomes more difficult to hit the target. The diagram's affectionately known as the wedge, so I've created my own, and I call it the goalposts. It does have, Mervyn Richards is the other co-author of the wedge diagram, and I did run it by him, and he did reluctantly approve of it. So it's okay for me to show you this. But I need a little bit of assistance from a friend of mine, who I believe you might be familiar with. Do we have any sound? BIM level 0, I think we've got that one covered. Everybody's got that covered. That's just 2D lines and text. BIM level 1, I think we're pretty much there. So the definition of BIM level 1 came with BS 1192 2007, where we were using 3D as well as 2D. BIM level 2 is a little bit more tricky. It's a pretty good player. I think BIM level 2 is, well, we've pretty much got it covered in the UK, as Stefan was saying earlier. We're trying to treat it as business as usual, but more and more countries are coming on board with the concepts of BIM level 2. Oh, that's a bad miss. BIM level 3, we're not quite there yet. And as I was saying, the goalposts seem to keep moving, and it's quite difficult to achieve. I wasn't quite sure how to describe BIM level 3 here. I've called it fully connected digitization. In the UK, it's called the Digital Built Britain programme, which is an attempt to create more inclusivity across the entire, not just the construction industry, but manufacturing, and kind of bring them into the BIM processes as well. Because I do believe it is still all BIM anyway. We just don't really need to refer to buildings as such. We can refer to infrastructure. And at least 2 other speakers in other conferences that I attended recently referred to BIM as better information management, which is what it is really. You can dress it up as much as you like, but it's all about managing data, managing information much more effectively and inclusively. You're going to have to stick with me on this one because I might lose a few people. This is my view on the future of interoperability, which is a big word in English. That's a very big word in Polish. I'd like to tell you the story of the organ grinder and the monkey. A Polish friend of mine, a colleague of mine, helped me with this translation next because I came across this quotation from Winston Churchill, which is, "Never hold discussions with the monkey when the organ grinder is in the room." Google Translate just didn't cut it in this case, so I needed some help, and I hope that's correct. But the organ grinder is the guy who turns the lever on the side of the organ and it plays a tune, and then the monkey dances to the tune. And obviously that phrase there from Winston Churchill means, you know, and I'm conscious that there may be organ grinders and monkeys in the audience, so just be careful out there, okay? So inside the barrel organ, we have this wooden drum with hundreds of metal pins hammered into the wooden drum. And as the organ grinder turns the wheel, the drum rotates, and then the pins in the drum play the instrument live. Okay? This technology dates back to the 1790s. The 1790s. So back in my shed in 1790, I could have constructed this barrel organ, and my next door neighbour might be constructing his own barrel organ, but it's got different sounds. But I could agree with him that we use the same drum size, the same spacing of the pins, and we could just swap drums, and then we've got open BIM music. So the later technology used rolls of paper with holes punched in them, and they move across a passage of air blowing through the holes at a constant rate, and then the air plays the pipes in the organ. And you can see there's an open standard here. So you can select your piece of music, put it into the device, and then switch it on, and it'll play you a different tune. But the instrument is playing live. This is the kind of up-to-date version, and I dabble with electronic music myself. Instead of punching holes in paper, you're punching holes in the computer, which is something we'd all like to do sometimes, isn't it? So what we actually do is just record keystrokes into the software, and then we play those keystrokes back, and that plays the instrument live. This piece of software is known as a sequencer. So this would be a sequencer, and this would be a sequencer, and IFC, maybe that would be a sequencer, maybe. You see, I record my building using ArchiCAD, and I play it back using one of those products. The thing about music is, it's black and white. It starts, and it stops, and it's high, and it's low, and it's long, and it's short. The rules of music are very simple, okay? But with IFC, it's kind of all over the place. An IFC is actually a text file. So I don't think it really is true open BIM. True open BIM is something that you can see here. This is something I saw demonstrated last year. They call it algorithmic design. I think that phrase was invented by some boffin in a laboratory. But I would call it dynamic interoperability or real-time BIM. Real-time BIM. It's real open BIM. Over here we have ArchiCAD, and then on the left we have Rhino, completely different program, and at the top we have this software called Grasshopper. And by changing the elements of Grasshopper, we can determine how the two programs behave in real time. So if changes are made in ArchiCAD, they will happen in real time in Rhino. No IFC there. So if you can imagine the concept of a BIM hopper, where all CAD programs, all BIM platforms communicate together. We're probably a long way off that kind of scenario, but already I've seen products out there that achieve this. Grasshopper was last year. Fuser, it has been around for a few years now, but we only came across this in the last few months. On the left-hand side, in this case, we have Revit, but it's also ArchiCAD and SketchUp compatible. And on the right-hand side, we have Fuser. And this nice lady from Hong Kong gave us a webinar just a few weeks ago, and I was on the line, and two of my directors were on the line in different offices. And the lady from Fuser, she picked up a piece of furniture, in ArchiCAD it was then, and she moved it across the room. And then with no refresh, that same piece of furniture moved in Fuser. And it's real-time VR, real-time rendering. And then on the line I heard Lorraine say, "Did that table just move?" She was that stunned at what she'd just seen. And it is bi-directional. So you can move the tables and chairs around in Fuser, and they will move in Revit or ArchiCAD or whatever you've got connected. Another product that I researched recently was one called Revisto, which some of you may have heard of already. Some contractors are already using it. Online collaboration. Again, it is Revit and ArchiCAD compatible, as well as AutoCAD and one or two others. You can upload your models directly from your BIM platform to the cloud, and then they'll join together, and you can collaborate in real time in the cloud. And then, of course, as Tamas demonstrated earlier, we have Graphisoft BIMX, which has a much neater interface and a much neater way of actually displaying drawing information over the top of a model. So there you have it, separated at birth, dynamic interoperability, and it's only taken 220 odd years. We're back to where we started. Real open BIM. Thank you.